And we are live again. I think so. Hello. So yeah, welcome back to the Pajama podcast where we discuss on random embedded stuff. Uh, our hope is and our intention is that we have casual chats around embedded systems and just end up motivating and exposing essentially how relevant the field is. And as part of the discussion, for today, what we are going to do is we are going to delve on the C language, its relevance, and then randomly anything that crosses our mind, relevant to embedded systems, of course. So yeah, with that, maybe let's just go around the table and talk about what your opinions on the language are. Do you think it is relevant? It's not relevant? Is it a language that's dead already? Nobody programs in, and so on and so on. Maybe I'll just pick Rajat. Go ahead, Rajat.
So just a funny story. So when in 2015 I started working with Atmel Semiconductor, there was a hype around the industry saying C is dead and there are languages like Rust, etc. that are going to take over. And it has been 8 years since now, and I'm yet to come across a single code base that is written in Rust.
Right.
So yeah, C is definitely not dead, and I don't think C will be dead anytime soon. The fact behind that C is so relevant to embedded systems, like this, I'm yet to see another language that is so beautifully written for embedded systems, because you just look at the language and you understand what's going to happen in the hardware, and that is a very important thing I look in a programming language now. Maybe I started
Right.
if I started as a software engineer, I may not appreciate that. But since I started my career as a hardware engineer, working on hardware, I appreciate that a lot, because when I look at the code, I just simply understand what is going on. I sometimes I don't even look at disassembly to understand why something went wrong in the hardware.
Right.
And the fact goes back is most of the operating systems still today are written in C.
Right.
Most of the compilers are written in C and C++. So wherever
Right.
it comes to performance, wherever people start talking about performance, the only languages that I see is C and C++.
Right.
And that's a big statement. Are there languages that improve upon it? Yes, there has been talk about Rust happening, but that
Right.
has been talking. I have tried to learn Rust several times. Is it a language that can replace C? Maybe, yes. It has the potential, but not anytime soon. Because
Right.
the places where C find itself, the devices for that has a lifetime of 15, 20 years. So it's
Right.
exactly like saying, I got an EV today. Maybe next year all the cars in the world will become EV. It's exactly comparing like that. So I don't
Right.
think
Right.
C is going anywhere anytime soon.
Right. So you're suggesting that you anticipate that if Rust takes over or replaces C, there's still a decent ramp, many
Yeah.
years to come
If I
when
have
Rust
to
will
say an
replace. Yeah.
estimate, even if let's say today every developer starts learning Rust, tries to put Rust in embed, etc., it may even take 15, 20 years before we see Rust becoming a very common language for embedded systems.
Fair. Okay. Right. Right. I think I agree with that, given that specifically for automotive, like the life cycle
Yes.
of a product is like 15 years. So anything developed today will last for another 15. And then if C was the choice for it, then the firmware still needs to be
Yeah.
in C. Fair. Okay. Go ahead. Do you want to talk about the example of Linus and his lecture in one of the universities?
So Linus is a funny guy. I always appreciate him. You know, I relate to him a lot, maybe to his bad side as well, where he talks a lot of things about people. But
Mhm.
I do agree with him. And I remember, I think you are talking about the lecture that he gave at the college where he was like, C++, what a horrible language.
Right.
Yeah. Yeah. So I guess, yeah, a lot of my choice, like why I decided to stick with C, has to go back with that lecture from Linus, where he puts it very beautifully why C is the way it is, why Dennis Ritchie chose those keywords and not the other keywords. Why Dennis
Right.
Ritchie let pointers be there and not have a garbage collector sitting over there. And
Right.
I think there was another lecture in a CPP DevCon where the committee was explaining that a lot of features that Rust has already exist in C++ and
Right.
C++. But the reason they are not uh, as enforced as Rust is because the ideology of all the C-based languages goes back to Dennis Ritchie being there, saying developers should have power over the programming language.
Right. Right.
It should not
Right.
restrict developer from doing a lot of stuff. And I guess that's where Rust takes a different ideology, where it restricts a lot of things by use of the compiler.
Right. Right.
Yeah.
But
Both have
that's
their
like
pros and cons. Yeah,
Right.
but I guess if specifically talking about programming hardware at a very low level, I think I'm going to stick with C.
Right. Right. Yeah, I think I second that. And I have my opinions on, C and Rust, but maybe we can let Dave and Mohammed, speak to it. Go ahead.
Well, I guess C is a very beautiful language. Why would someone say it would be dead in next few years? I love C, right? I think every one of us started with basic C language, right? When we started our college, this was the first language introduced to us, right? And
Definitely.
I
Yeah.
think every syntax, everything about this language is very beautiful, beautifully simple, right?
Right.
Any a person who doesn't have any past experience working with the language can go and start learning this language, and it would be very easy for them to
Right.
get to a point, right, where they can develop
Right.
softwares. And I think in the industry, right, if you look around, every device that we work on uh, is running some software which is written in C, right? Most of the operating systems around us are written in C, right? And I think most of the data center servers, a lot of things, right, are written in C. And I don't see any foreseen time near future. I agree to the Rajat that C would be replaced because there has so many infra around
Right.
C, right?
Right.
Devices executing C, that it is very it would take time for completely replacing it by any other programming languages, right, like Rust or
Right.
anything, right? And I think one good thing about C is that most of the programming languages that people use today,
Right.
Python, Java, C,
Right.
C++, right?
Right.
All these are some form of derived from C. You can infer how the Python code would look like, right, if you have
Right.
the C code, right? It's
Right.
it's very easy to jump from C to Python because of the syntax similarities and all, right? If you talk
Right.
about Java, it is also similar, right? Syntax are inherited from C and C++, right? So
Right.
I think for a foreseeable future, I personally don't think that C would be replaced that easily because of vast use of its existence in the
Right.
universe, right? So
Right. Yeah, I think that I'm convinced with that. Well,
right,
actually, me getting convinced is not a thing because I have my own opinion.
right,
But what you mentioned makes sense to me,
right.
whether or not I'm
I
biased.
think
But
so. So there was one time when I was in college, and one of the person called me and asked me that what all languages do you have you learned, or what all languages do you know. And
okay.
I just mentioned that I only know C language.
Okay.
I think from the C you can easily infer to C++,
Right.
but I
Right.
don't know about Java. I don't know about Python. I was
Right.
in third year, and that person mentioned that I know most of the languages. Like
Mm-hmm.
the people in my college are working on C, C++, Python, Java, the
Right.
JavaScript, and a lot of things. But
Right.
I mentioned him that learning the language is not key to
Right.
success, right? All you have to do is you just learn a single language
Right.
and then try to develop your mind, right?
Right.
And that you can easily figure out, you can take a course and then easily figure out another
Right.
programming language
True.
in a day or two, right?
Right.
So it's that easy if you know the C and C++, right? So
Oh
yeah.
yeah. I think I definitely agree with this one point, which is, if
Right.
you know one language, it's easier to learn another language because
Right.
each language pretty much offers that basic set of, being able
Right.
to write functions, write loops,
Mm,
conditions, and all of that. And of course,
right.
then, languages like Python and C++ have their own nuances
Mm,
in terms of feature set that they offer.
right.
And I think that takes a while to learn and,
Right.
internalize. But in
Right.
general, I agree that if you know one language, pretty much
Mm,
you can extrapolate and
right.
learn other languages. Yeah,
Mm.
right. Mohammed, do you want to comment on your views of the C language?
Uh, Yes, yes. First of all, since we are talking about relevance, I would like to add, one point. Uh, this is not the first time where, people have raised this debate where
Mm-hmm.
the question was asked was, hey, is he dead in near future?
Mm-hmm.
And it has kind of stood the test of time since past 50 years. And I think it will
By the way,
keep on.
Mohammed, I have to interrupt you. Are there other tabs open with the same software?
Oh, yes, yes.
Okay, could you kill that?
Okay,
Yeah,
I
go
hit
ahead.
that.
Sorry to
Okay,
interrupt you. Go ahead.
no
Yeah.
problem, no problem. So yeah, I think the relevance part is like C has stood the test of time since 50 years. There were so many languages before C, so many languages which came after C, but only very few survived, and C definitely is one of them. And I think the if you look how broad its sort of versatility is in terms of what all systems have adopted C, what all system has have chosen to write their software in C. I think that debate would pretty much settle itself once we get to know where
Mm-hmm.
all the tentacles of C are.
Right.
Personally speaking, I think the greatest thing which I like about C is its simplicity. I mean, it
Mm-hmm.
doesn't take much to sort of, get to a point where you are just able to write one statement in C and you can just predict almost always correctly how would the relevant code look
Mm-hmm.
like in assembly, or rather, what uh, changes I make to a particular statement to get the maximum out of my hardware, be
Right.
it utilizing the cache systems correctly, or making sure that the memory, the SOC memory map
Right.
is accessible. Those all little things are very, very easily manipulatable in C. And I think that's like
Right.
my biggest uh, takeaway when I started learning C. And I think it has really helped me in that sense.
Mm-hmm.
One point I would like to add, to what Dave said was, I think when we were in college, there was pretty much only one option for us to get us introduced and get us started in programming, which was C. And I
Right.
think that was great. But nowadays, I look like the curriculum have introduced Python and other languages as
Mm-hmm.
the first stepping stone, which is great. No denying that.
Right.
But in some sense, people can kind of get distant from C when you start with Python. It's like, hey, I
Right.
can do this in Python in one line. Uh, why it is that I have to write, like a bunch of code just to get that out? But I think if we can address that,
Yeah.
that piece where introducing programming language, in starting off with Python is fine, but parallelly we should have like
Hmm.
a segue into languages like C, which are very much relevant and which are the
Right,
cornerstone when we talk about embedded systems.
right, right.
Hmm.
Fair. I think that's a good point. Um, uh, well, obviously, I agree with everything that the three of you mentioned, and I personally like C specifically because it's close to hardware. It really represents the hardware
Yeah.
very accurately, and that's something I struggle to do with C++, for example. Now, both the languages are like extremely performant, right? No question about that. And in some, in some presentations, I have seen that C++ can actually also compile to slightly smaller binary size. So yeah, C++ has its advantages, not denying that at any point. But for me, C, because it is very close to the hardware, it's very simple to comprehend. And I can, as Rajat was mentioning, every time I read the C code, I can see the assembly, and I precisely know what the CPU is going to do. And so in such cases, if I'm doing a debug, I know when to doubt the hardware and when to doubt the code,
Yeah.
right? So that's
Right.
something that is my again my opinion about C. And then going back to whether this language is dead or not, well, I would also argue in the favor of that it is still one of the most relevant and most used and coded in language. And the reason to that is very simple. When you consider any other language, with maybe exception of C++ and Rust, uh, for any embedded related things, you would use C++, and maybe in some cases Rust, right? Let's give that to Rust. But then all other languages, you need a machine that's running an operating system to run it on, right? JavaScript,
True.
for
True.
example,
Yeah.
runs on top of an operating system. Python runs on top of an operating system. So these languages, non-C, C++, and Rust
Hmm.
languages, they require like an operating system
Right.
base to run on top of, which means the level of things you can do with those languages are limited within the box. Server, desktops,
Right.
or maybe in certain cases, even
Hmm.
mobile phones. Now,
Right.
when you think of where all C is used, well, it's in your ovens, it's in the TV remote, it's on my watch, it's there in the headphones, it's there in the car, like it's there in fact on every chip within
Hmm.
the desktop as well. The Wi-Fi chip has a processor, the Bluetooth chip has a processor, the display unit has a processor, and all of these processors, because they do like very specific thing, the firmware would be written in C, right? And for those reasons, I feel C is the most coded in language, uh, but it doesn't get the spotlight because making something tangible and useful instantly is possible in languages like Java, JavaScript, Python, and that's why the focus goes on to them as the useful
Hmm.
languages. But of course, C by any stretch of the imagination is not dead, and it can, yeah,
Yeah.
it has just as much scope. It's just that there are not enough people who who are willing to learn C as their first language,
Right.
which is very odd and strange to me because, well, personally, I only know C and Python. I tried learning C++. I can understand that language. I can't think in it. That's a problem. And pretty much any feature that C++ has, I can think of a way to do it in C, and then that's a
Hmm.
problem in terms of learning C++,
Yeah.
right? But surprisingly, C only has 32 keywords. That's all. Right, and the features are straightforward. And when people say that's the difficult language, I don't understand it. Maybe it has to do with the fact that you have to learn that language by first trying and understanding
Yeah.
how the CPUs work, at least the programmer's model of the CPU, and then work your way upwards to the language.
And I
But yeah,
suppose it doesn't have like readily available libraries to ease your
Oh, yeah.
job. That's the biggest pain point when someone is starting, their
Yeah.
journey in coding. And I think, to aptly put, Piyush, your analogy of why it is not visible, of, what all systems use C, I think it's like the foundation of any big building,
Right.
where foundation is not visible, but that is like the key in
Yeah.
making sure that the building stands for 50, 60 odd years
Right.
or even more.
Yeah, and one of the things I'm able to think of is the C Python implementation of the Python language.
Python, yeah.
Yeah, Python. It is, well, it's written in C.
Yeah.
And there's a reason to that, right? And yeah, so again, just to maybe summarize all four of our views, which maybe is the biased view, but at least we don't see around us C being dead. In fact, we have difficulty hiring engineers who know C. It's such engineers are rare. Yeah, cool. So yeah, that was on the relevance of C then, right? So could we now maybe move ahead to talking about what are the features of that language that you like the most, and what are like your favorite aha moments from using C? Any feature of the language that you like. Again, Rajat, do you want to go first?
Yeah, so you know what, before we move on to that topic, I want to bring
Sure.
so 32 keywords is not a limitation. I really appreciate that.
Yeah.
Because irrespective whether I open the code written in 2015 or 2022, they look the same to me. While the same doesn't happen for other big languages.
Right.
Like you open the code after a year, it looks alien because suddenly there was a new spec and some new generation was inherited to that spec rather than the previous spec.
Yeah, I mean,
true,
just
true.
one line, right? Migration from Python 2 to Python 3.
Oh, exactly. This is the exact thing I was thinking of. Everything, like I have to now relearn Python again, just because I don't know what changed from 2.7 to 3.
Yeah.
And I know things changed a lot because nobody now uses 2.7. Well, not nobody around me uses 2.7. Go ahead.
So I would just say that there takes a lot of things into deciding a language, not just by looking at it. So like if you go towards the why C became the choice for embedded is because people wanted to run things very fast.
Right.
And that's the thing they didn't get in Python or Java or anything else. And that's why people stick to C.
Yeah.
Right.
A lot of languages came, like I know Java came with a perspective that it will replace C. Nothing happened. Java find its space in GUI, GUI interfaces, etc., but never replace C. There was a part where even ARM decided to put Jazzel instructions that can fasten up the Java bytecode.
Right.
But nothing happened on that perspective.
Yeah.
So there's maybe for other languages like web development, etc., JavaScript makes sense over C because they want very high constructs to be readily available rather than implementing it. And yes, there's downsides like package managing is a big downside of C. There is nothing called package manager, nothing called a build manager.
It just
which is there in modern languages.
Yeah.
So there was a lot of things. And for embedded, I think the criteria that's going to define, even for upcoming years, which language gets used will be the speed of execution, the bottleneck it generates between assembly and the actual language.
Right. And I suppose
as
also
they call it, zero cost abstraction. If it is not zero cost abstraction, it's not welcome in embedded.
Right. Yeah. I think as long as any language gives developer the full control of the hardware and doesn't do any fishy stuff or behind the scenes stuff, no abstractions, then I think that's the best suited language for embedded. Yeah, that makes sense. Yes. So okay, then going back to the features and the aha moment, can we go around the table for that? Okay, who wants to go first?
What I really like about C is it gives me the feeling that I can control literally anything.
Yes.
If I want this variable in Flash, I can put it in Flash. If I want this variable in SRAM, I can put it as SRAM. And I have total control on where this thing goes.
But Rajat, I just want to call out this, that being able to control where the variables go isn't that more of a linker thing?
It's actually a combination of both.
Fair.
So
I would
even
agree
though
with that.
you have to, the specification has to allow you to do that. For example, it can enforce and so linker does allow you to do that. So the C as a language creates sections, and linkers can place them as per the user's instruction.
Fair.
But
Yes.
where is linker for Python?
There is none.
So, so the language, so I would say this, and I think this is not Python's fault. Python was never designed to be a systems programming language.
True.
So, and I think that this control of where the memory goes, where things go, are strictly limited to the systems programming language. You will find it in C, you will find it in C++, you will find it in Rust as well, where you can decide where to put things. And sometimes we need control over that, because in systems programming, you need a lot of control where things are going. I can give a scenario. For example, that I have worked in devices in the past where TMA specifically needs its descriptors to be placed in a specific memory.
Right. True.
Else it will not work. And how do you do that when you don't understand the memory structure?
Right.
So, and C gives you control over that. C, and I think that's a good thing to me. C allows me to have a total control, and I really appreciate it.
I mean,
Right.
it allows
I
you
think
to.
It gives you a it gives you a virtual feeling of
You are the god.
Apuni yaha
Yeah.
dada. Apuni yaha dada.
Makes sense.
Yeah,
Mahmad, you
I
were
was
saying
just wanting
something. Go
to,
ahead.
pile up on what Rajat said. Like, it gives you control to just add any random assembly instruction in anywhere. Like, hey,
Yeah,
you are the
exactly.
boss. Do it,
Yeah.
handle it with care.
We trust you.
Yeah, we trust you.
Also, again, going back to that one specific thing, which is adding assembly in C code. Again, isn't that a compiler thing? Isn't that a compiler feature usually? Like
Yes,
GCC
I
provides
agree
you.
I agree with that. Yeah. It is a toolchain feature, but I don't see any. Most of the higher level languages offer that stuff. Yeah,
Providing even that. Yeah, okay. I agree with that. But I just wanted to
true.
kind of call out that one thing, because the C keywords by themselves, the 32 keywords, let's say, they do not give a way to write
Fair,
assembly in C, but the compilers
And I
do
suppose,
provide you with
I think we kind of are mixing
attributes
a
or.
lot of things when we say, a lot of features which we're talking about are kind of, tool chain driven, in the sense compilers
Right.
and linkers are providing you that because there was a need for it, basically.
Yeah. Right. And what I've noticed is the language. Once you learn it, pretty much you can get your things done, even if there are new variants of the language coming up. Again, going back to Python, once Python 3 came, most of Python, not most, but a decent number of things from Python 2.7 wouldn't work. It wasn't backwards compatible. Right. Yeah. Go ahead, Dave. Do you want to talk about a feature that you like in C?
Yeah, I
Or
think
something that you use
I
on a daily
wanted to
basis?
talk about pointers, but I think Mahmad took it away.
We are just,
Yeah.
emphasizing the fact that how
Right.
cool pointers are, and both of us are talking about the same thing.
Yeah, it's my favorite, man. So I think how amazingly you can use pointers to solve a very complex problem, right? You can and I think you can see the memory in front of your eyes, right? If you're using a pointer, right?
Right.
You know the memory layout. Okay, if I allocate this, where it would go, what memory I would get, right? And then when I do the pointer manipulation, I know what is happening underneath hardware, right? And that's, I think, fascinating. And I think it's difficult for me to realize that thing in, let's say, I'm doing Python, right? If I'm doing Java, right?
Yeah.
I don't know what is happening underneath.
Yeah.
I literally don't, right? I know that, okay, this memory may be, allocated in the stack or the, heap,
Heap.
right?
Yeah.
But I literally don't know a lot of things when happening underneath, right?
Yeah.
But in case of C, right, I know I can get a complete picture of what is happening. I
Right.
can start with a simple pointer and then build a complex file management system, right?
Right. Right.
And it
Right.
would allow me to do that, right? And
Right.
I could literally go and and understand that each part of that code, how it is happening, how it is being uh, you know laid out on the memory, right?
Mm-hmm.
So that's one of the fascinating thing that that I like about C. And of course having that sense of control of your hardware, right?
Mm.
That I guess only C provides.
Right.
You could do anything with it, and that's amazing.
Yeah.
So whenever I think of pointers and people bringing dangling pointers, etc., somehow I imagine the scene from Hrithik Roshan movie where Hrithik Roshan saying, "Mummy, मेरी शक्तियों का गलत इस्तेमाल हुआ मम्मी."
Right.
Is this the
Very
Krish? I think
shakti
Krish
All right.
reference.
Krish.
Yeah. I'll
Yeah.
try to find out that meme and flash it on the screen. Yeah.
Yeah.
मेरी शक्तियों का गलत इस्तेमाल किया जाता
Imagine
है. Right.
pointers saying that to
Right.
Pointer crying.
who would be the mummy
Okay.
here?
That's.
C language?
Oh yeah,
Dennis
Dennis
Ritchie?
Ritchie.
Maybe, yeah.
Maybe.
Fine.
Dennis.
Do you want to talk about Dennis
Yeah,
Ritchie,
yeah.
Mahmad? You were
Yes,
mentioning.
yes. I was keeping it, for the end of the podcast. But anyway, since we are here,
Okay. Yeah.
I mean, I'm kind of out of words when it's like, I have so much to talk that I kind of freeze, like, hey, where to start? But so first thing,
Okay.
I remember when he died. I think it was in 2011, when I was
Mm-hmm.
in 12th, just going for college, and that is where we were first introduced to C. And
Mm-hmm.
his death was kind of clouded completely by Steve Jobs' death, who kind of passed away a week or two earlier. I mean, he was
Mm-hmm.
Steve Jobs was a legend in his own right, no doubt about that.
Yeah, of
And
course.
I mean,
Yeah.
it was a big loss to the tech world. But the fact that
Mm-hmm.
Dennis Ritchie was also a very shining star, and we kind of did not. I mean, at that time, social media did not give that much
Mm-hmm.
importance, or uh, I mean, I should say the
He
coverage,
was not
to that
yeah.
really saddened me. I mean, Dennis Ritchie, I think,
The hero
is one
kind
of
of
the main
silently passed
contributors
away.
why we
Nobody
have
noticed.
this much of a technology. I mean,
Oh
it may
God.
not be that
Looks like this time I'm out.
evident again, because it is, whatever he has done in developing Unix or C is kind of hidden behind layers upon layers. We don't even know, or a normal world doesn't care, hey, my Bluetooth has a
Oh my.
microcontroller which runs C, but it is working because there is C in
Everything
it,
is
which
just
is
flaky.
doing its job without ever crashing. So yeah, I just wanted to just honor him, in our podcast for 2 minutes. Like, hey, I mean, thank you, Dennis.
Yeah.
I think he was the Tesla of computer science.
Yeah, I definitely, I mean, plus 100 to that man. Yeah, a man, ahead of his age by a lot of, by a margin, by a huge margin. And yeah, he was the Nikola Tesla of computer science.
And I
I
think
guess we
it's
lost our host.
yeah.
We have been facing technical difficulties today.
ये पार्ट
ये
कटने
part
वाला है.
पीयूष भाई का जॉब बढ़ गया है भाई.
Hmm.
Okay. Cool. So maybe if we go back to the discussion on the cool features in C that I personally like, I would say that it's the combination of pointers, structure pointers, and function pointers. well, at the base of it, what I'm trying to convey is two important features: the fact that it allows you to group things together as a struct, and then the fact that you have a pointer. So now what you can do is you can put the data and function pointers both within a struct, and then that's like a nice object tree presentation. You can keep the data and the functions that operate on the data together. And I think that's very cool. By the way, I should also mention that this is above and beyond what all the features that you have mentioned. Right? I absolutely love those. But if I were to, add an extra, extra separate feature, I would say it is the structure and the combination of function pointers. Yeah. Okay, cool. So with this, maybe let me go to let me put a question that we did not meditate on earlier, which is how should somebody go about learning this language? What would be your recommendations? Which part of the language to not miss? What to look out for? What is usually hard, but you have a good, easy explanation for, and so on and so forth. Yeah, Mahmad, do you want to go first?
Yeah, sure. Well, I'm just kind of thinking about how did I start learning C. So for me, it was very conventional. It was a college course, and initially you'd be like thrown. It would feel like you're thrown, with things you are just asked to assume and just memorize. Like, for example, inclusion of headers. Like, why is it there? Why do we need it? And then void main. What is main? What is void? It all started like that. For me, the journey was that I could have quit C had it not been mandatory. So the fact that I continued was because the college required, it was mandatory, and that kind of incited me to go deep and see, hey, what does void mean in C? And I mean, I'm really thankful that when I started college, at least the era of internet had dawned, and I could just go Google search, get the relevant info. Sadly, I still don't find like any much improvement when it comes to learning C when a person who is just onboarding. There are so many tutorials, and there are so many tools which would develop that programming thinking. There was a language where you could just plug and play, just like Lego pieces. I'm forgetting its name, which some of the university developed. Scratch. Yes.
Scratch.
So that helps. Yes.
MIT.
That helps in inciting the the thinking in terms of programming language thing, but it doesn't necessarily directly translate to C. So I mean, my suggestion would be that I know the journey is hard. One of the motives for us to start, this was to some way contribute in any sense we can, in any way we can, and we'll definitely try our best. But till then, I should say, just Google is your friend. Please spend some time in actually understanding, okay, why do I need to do that? Ask that question. What are headers? Why do we need to include that? What are keywords? I mean, keywords in the sense, why specific keyword needs to be written when you are declaring some data type. What memory the data type consumes. How it translates to assembly and stuff like that. I know it is hard. I know I'm asking a lot. But believe me, once you go into that habit, it will pay you heavily in the long run. That would be my suggestion.
Cool.
Well, I think so. When I started learning C, I learned it, I think, in the hard way. So I try to remember everything. There wasn't any logic behind. I just crammed because of the exams. So one of the interesting event that I remember now is that I had to cram for loop, how it works, and each step.
Yeah.
Like
Yeah.
exam was tomorrow, and there was
Yeah.
one person from mechanical engineering. He taught me how a for loop works,
You were the software guy.
and I was this computer science guy. So you could see how hard it was. I think it was introduced in first semester, and
Okay.
when I did not have any laptop, or did not have any experience working on computers, and I did not even knew how to type.
Right.
So that was a hard way to learn C. But nowadays, we have ample resources. Everybody
True.
is having a computer, laptop, right? And there are a number of resources online
Right.
that you could go through. And one of the interesting it makes easy for you is that when you learn C, you try to understand every stage of compilation, execution, assembly, assembler, and all of these things, right? How linker works. So there are tools, right? You have a you learn about a program, you write a C program, right? And then you use compiler to know what assembly it generates, right? So there are some flags that you could provide along with the GCC command, and you could see the output of the compilation, right? So always try to understand end to end, right? Don't just focus on the C programming. Also focus on how it would compile, how would it would assemble, and then do the linking, and then end to end flow, and how it would be executed in the hardware, right? So I think understanding that part would go a long way. You would understand it without cramming the whole syntax part. So that is what I had learned, and I would recommend people do that. And that's the easiest way. If you do any other way, that would be very difficult. So yeah,
It would just sound easy,
right.
but it
I
would
mean,
not be.
I think it goes without saying, like, whatever suggestions we give, we are demanding a lot, from a person who
Oh,
is just
absolutely.
starting his
Right.
seizure, his or her
I
seizure.
suppose
Right.
true, but in some sense, going into the language, knowing something about it based on what we are saying, my hope is that makes the journey a little bit easier because you
Easier.
always know what's coming your way.
Right.
That makes makes the suffering worth it.
Right.
Right. So take the path. Yeah. Rajat, do you want to speak to the question?
What was the question?
Okay, it was
Okay.
it was what recommendations do you have for someone just getting started with C or considering learning C?
Okay. In my opinion, the hardest part about C is pointers. And if you really want to learn C, the art of learning C is mastering pointers. If
Right.
else for while it's common in all constructs, it's easy to understand.
Yeah.
But if you really understand what that star and ampersand means, like your wisdom is to understand that star and ampersand cancel each other. If you put a star and ampersand, that means nothing. So they are opposite to each other. If you understand that perspective, you have mastered C.
Right.
So I would say play with pointers how much you can. Don't feel shy of creating as many segment folds as you can. That's the art of learning C.
Yeah.
You learn by crushing it.
Yeah.
I think I would upvote it plus 100, 100 times. It's clearly the most important thing in C.
Right. Right. Yeah, I think I have suggestions along the same line. but for some reason I feel that we have a responsibility to quickly explain
Yeah.
what a pointer is. So I'll just go ahead and do that then. So a pointer essentially is, a container that is having a number, and that number will be a memory cell, right? So that number is representing, so to speak, address of the memory cell. And then the idea of using pointers to manipulate data or memory regions is that you use the addresses to memory locations to modify content that the address has. That's all, right? So pointer is an address, and pointer manipulation is you using that address to
Yeah.
modify content within the address or held at that location. Yeah, and yeah, I think I'll leave it at that in terms of what pointers are. Yeah, I think we're back again. So I was kind of proposing how one can go about learning C. So I was mentioning that the right way to do so, in my opinion, is to start with something called the programmer's model of a CPU. Understand also the programmer's model of the memory, because CPU and memory are kind of, you need those to do anything computationally. And then kind of understand a little bit of assembly just to understand, how to program the CPU. And then from there, ask the following question as to if I write like a really awesome program in assembly, and let's say I have a processor of architecture X, and my friend has a processor with architecture Y, and he wants to run my program, then he won't be able to, because the assembly I used to write is for the processor X, for the architecture X, and wouldn't work for architecture Y, which then means that he would or she would or they would need to rewrite all of the program in the processor Y's architecture. And what C did was, back in time, it essentially solved this problem. It introduced that extra layer of writing the code in C, and then you could compile it down to not compile, but you could convert it into like the assembly for processor Y, architecture Y, and architecture X independently, and it made the programs portable, so to speak. And once you understand that angle, you understand every keyword and why that keyword exists in the C language, and then it becomes much easier to accept that language the way it is, and then creatively think in that language. So yeah, pretty much that's my opinion on how to go about learning C. Yeah. Okay, so maybe we can go around the room again, go around the table again, and take some closing thoughts. Anybody wants to answer any question that they remember from last time? Yeah.
Yeah, I remembered, few of the people in our last podcast request about, pointers, and in today's podcast as well, we talked a lot about pointers. Pointers, pointers to structures, functional pointers. I think because we are putting a lot of emphasis, we should also explain in detail what are
What
pointers, how
pointers
they
are.
work. Yeah.
Right.
And
Right.
and to rest of the folks here, we are working on it. You'll see videos soon in our channel,
Right. Right.
explaining that in detail. I mean, in as
Yeah.
much detail as we can.
Yeah. Maybe let's do a collective screen share kind of a thing where one of us does something with pointers and others kind of walk
Yeah,
through as to why that person is doing X
that's a
versus Y.
lovely idea. Yeah,
Yeah.
I would like to do that. Yeah.
Yeah. I'm remembering one question which was around, I suppose, interviewing for embedded positions, how one goes about it. Well, I think a general suggestion would be that, and this applies to like any interview, truth be told, but for embedded systems entry level interviewing, I think anybody who can think and solve problems in C or C++ mostly C, because C++, again, gives you a lot of libraries and standard library, all of that. So if you can either program in C++ without the standard library, or you can program in C with just minimal dependency on standard library like the printf, scanf functions. I think that's pretty good in the sense, be able to write C code, think about the solution in terms of C, reason about it in terms of how the CPU would go ahead and process or consume that code. What are the side effects of that code on the memory? Where does the data live? How is the data modified, and so on and so forth. Know how to do pointer manipulation. I think that is super important. All of these are like, these will set you up for a decent chat in the interview. Of course, usually the interviewer is seeking very specific things, and that depends on which company and which interview you are in. But at least you will have enough vocabulary to have like a meaningful conversation. And a meaningful conversation around a technical topic goes a long way and earns you a lot of brownie points compared to, oh, I know how to solve this problem. I solved this problem, but still I wasn't, accepted into the company or whatever. I suppose one of the fundamental things is, in an interview, you should never walk in to validate your abilities as an engineer, right? An interview is not where you take a confirmation as to how good of a technical person you are. You should never do that. An interview usually is an exchange of ideas where one person is trying to understand whether or not you will fit their team naturally. And if they conclude that you don't and somebody else does, then that's that. It doesn't speak anything concretely about, you being, a bad technical person. You should never walk in with that. It should not be a scar on your self-esteem. Yeah, I think those are my thoughts on interviewing in general. Anybody else has any thoughts?
Yeah, I think adding to what you mentioned. So I have taken hundreds of interviews, and in every interview, what I look for is how a person come up with an approach. Are they able to questions enough to clearly understand what problem was asked, right?
Right.
I think one of the biggest uh, skill of a successful person is, or a technically sound person is, they ask a lot of questions,
The right kind. Yeah.
right kind of questions, right? And I think you would do the same. You always ask a number of questions, as many questions as possible, to clarify everything what you may be assuming behind the
Right.
scene, right? I think that's one thing. Speak out your approach, speak out whatever you are thinking to your interviewer. And that, I think most of the people are not looking about the outcome, rather than they are looking for the progress that you are doing, the process that you are following, the thinking, every single step that you are taking, right? So if you get that right, whether you have implemented a correct algorithm or you are reaching there, I think that goes a long way, right?
Yeah, true. I should also mention, while asking questions is a much appreciated thing, don't pester the interviewer with just like flood of questions. Ask meaningful questions. And the other thing is, don't freeze. I mean, having a brain freeze movement is all right. Everybody goes through that in a pressure situation. But I suppose don't go into a paralysis where you're like, I need more information before I can make any progress. Provide an approach, provide a skeleton saying, if this information was available, I would do this. Since I do not know it, do you have any input for me? Can I assume something here? Can I assume this API? Can I assume this layout of the data? Something like that. And usually the interviewer would allow you to have that assumption, right? Just because even they haven't thought through in that level of granularity and detail about that problem. They would know like how generally the problem needs to be solved and what they're going to look for in the solution. But if there are n solutions, then asking for things that you can assume also goes a long way. Yeah.
I guess for me is I'm fine if a person doesn't know 100% of things. That's the aim. What I usually look at the interview is the desire to learn.
Hmm.
And there's a difference between asking question and bullshitting around. And sometimes people don't realize it. They feel the interviewer may not understand. But the true fact is interview guesses up when you're bullshitting around, and he just
Yeah.
Right.
keeps on piling on it just to check how much you can bullshit around.
Yeah.
Right.
And then you
And
just bury yourself in
honestly,
the hole.
yes, exactly. So the aim is the real thing I always look in an interview is not whether he can solve the problem or not. What I majorly look is if I give him a direction to think about, is he able to think in that direction or not?
Right.
Right.
Because you may not be able to solve. That's the reality of programmer, right? If you can just listen to a problem and solve it, I don't think we need so many programmers. Solving a programming problem is like 3, 4 developers sitting together and debugging something when something
True.
crashes. I've never seen a
True.
single developer sitting and trying to answer why did it crash.
Right.
So
Right.
it's about taking ideas and gearing your mind into that direction. That can something go wrong in that? Can what if
Hmm.
okay, here's a hint. Can I build something on that? Can I make sense something out of that? And
Right.
that, as per me, is the biggest trait I look in a candidate when I am interviewing
Right.
anyone.
Right.
I have selected a couple of candidates in the past who were not able to answer my question, but whenever I gave them a direction, they were able to answer, think in that direction really loud.
Right. Right. I think that's another important trait in a competent engineer, which is they can self-navigate after a senior gives them a hint.
Like gradient descent.
Gradient descent, yeah. You know. And either I've seen people recover from brain freeze, reason through and come out of their own their own trap essentially. They landed into a trap on their own, and then they are like, "Oops." They if and in fact, folks that I personally like are the ones who land in that tricky situation, unanticipated tricky situation, a corner, so to speak, then reason out of that corner, recover, and then go down the right path. And of course, taking hints is all right. As long as the solution is not coming completely out of my head, I think it's fine. And that gives me a lot more signals in terms of how that engineer is compared to just me telling the problem, them solving it, and it's like done. It's like, yes, you
Right.
solved the problem, but I don't know anything about how you think,
Right.
which is what I came over to probe.
Yeah.
Yeah.
And I think
Seeing
it will
somebody
be
vulnerable is
really,
important.
yeah. I think the way I think of it that way is because I'm not interviewing for a real scenario.
Hmm.
Nobody is sitting behind my back that solve this problem in 30 minutes.
Yeah. In
Yeah,
real
in
life.
real
Yeah.
life.
Yeah.
So sometimes, so I will just say, unlike your school, there are step marks over here.
Yeah.
Even if you don't get to the final answer, there are step marks.
Yeah. And
Are
you're
there
you're
negative marks?
Yes,
oh,
Two,
if you
there
two
bullshit
bad.
around,
definitely
that's a
are.
negative mark.
Negative.
-1. Well, I
Minus.
suppose if I sense someone who would be difficult to work with, or would need like a lot of, let's say, hand holding to deliver on the default expectations of that position, only in those cases it's like no. And again, when I say no, it's not like the person is bad, or it's just that what we seek at that position is not what the candidate has at this moment in time, right? They could improve on it. Maybe in some other job role that feature is not even required. All of that. Um, But yeah, definitely, I think somebody, if we are hiring for a junior, then I personally look for someone who is collaborative, coachable, is willing to trust us with their career. Again, that's like a very tricky part. You cannot trust your senior with your career in like one interaction. But I suppose if they just bring their honest self to work, and if they don't know something, if they are honestly interested in learning it, as Rajat was mentioning, I think that's enough. That's great. And that's where I suppose a lot of people who are, let's say, embedded engineers but come from the background of physics or mathematics, I think it's not that they needed to have the mathematics of embedded. It's like they had that open mindset. They were open enough to new ideas and willing to learn, such that their seniors ended up teaching them a lot more than their college would. And I definitely know a lot of cases, examples of such great people on our team. But yeah, I think I usually look for open-mindedness, non-rude, and cooperative people. Yeah. Being a genius is nowhere on the list. And also, I don't know how to judge genius. It's usually understood that somebody is genius after they're dead. Like, usually. Right. I mean, Gauss was genius. Galileo was genius. Nobody, he was punished for that. Anyways, that was the point. Yeah. Also that. Okay, maybe.
I just want to add one last thing. Let us know if you want us to start, a Discord or a Slack channel, just so that we can reach out to you sooner, answer any questions there directly with lesser latency. So yeah, please let us know in the comments.
Yeah, it's going to be a nightmare to manage that if like thousands and thousands of people come up. But then we only have 500 subscribers now, so
that would be a good nightmare to have.
Yeah, sure. Yeah, happy to help in whatever capacity we can. Yeah, cool. Okay, so with that, maybe I'll close the call for today, and let's meet up sometime next week and discuss on something else embedded. Yeah, cool. Okay.
All right. See you.
Thank you for joining in.
Yeah, thanks for your time.